Black holes. They inspire terror in many people. According to folklore, black holes are massive, bottomless pits out there in deep space, invisible but ferociously gobbling up everything that comes near them. However, black holes are some of the most mysterious objects in the universe. What is the truth about black holes, and how big can they get? Join us as we marvel at the largest black holes in the universe. What are they? They're some of the strangest and most fascinating objects in outer space. Black holes are extremely dense, with such strong gravitational attraction that nothing escapes them. Not even light can escape their grasp if it comes near enough. Albert Einstein was the first to predict the existence of black holes in 1916 with his general theory of relativity. However, it wasn't until 1967 that the term black hole was coined by American astronomer John Wheeler. Physical confirmation of black holes took place, and the first one was spotted in 1971. The first ever image of a black hole came in 2019 from the Event Horizon Telescope EHT collaboration. The EHT saw the black hole in the center of galaxy M87 while the telescope was examining the event horizon, or the area past which nothing can escape from a black hole. The image maps the sudden loss of photons or particles of light. There are three types of black holes. They have been discovered by astronomers. The first is stellar black holes. These black holes, formed by the collapse of individual stars, are relatively small, but incredibly dense. Here is a prospective stellar black hole, can pack more than 3 times the mass of the Sun into the diameter of a city. This leads to a crazy amount of gravitational force pulling an object around the object. Stellar black holes then consume the dust and gas from their surrounding galaxies, which keeps them growing in size. There are up to 100 million stellar black holes in the Milky Way galaxy. Another type of black hole is supermassive black hole. These enormous black holes are millions or even billions of times as massive as the Sun, but are about the same size and diameter. Such black holes are thought to lie at the center of pretty much every galaxy, including the Milky Way. However, there are more supermassive black holes than stellar black holes. Scientists aren't certain how such large black holes spawn. However, once these giants have formed, they gather mass from the dust and gas around them, material that is plentiful in the center of galaxies, allowing them to grow to even more enormous sizes. The third type of black hole is the intermediate black hole, which recently research only revealed. Such bodies could form when stars in a cluster collide in a chain reaction. However, several of these intermediate black holes existing in the same region could then eventually fall together in the center of a galaxy and create a supermassive black hole. Black holes have 3 layers: the outer and inner, event horizon, and singularity. The event horizon of a black hole is the boundary around the mouth of the black hole past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, one of the scariest places one can ever be, where the object's mass lies, is known as its singularity, the single point in space-time where the mass of the black hole is concentrated. You can't see black holes like you can see stars and other objects in space, so astronomers detect them by radiations coming from the black holes. These radiations are generated as dust and gas are drawn into the black holes. Now, which is the better black hole to fall into? Is it the small ones or the bigger one? Surprisingly, you would probably survive for longer if you plunged into a supermassive hole than a small stellar black hole. This is because tidal forces are lower at the event horizon, the point of no return of a supermassive hole, than they are at within a smaller hole. This means an unlucky astronaut might be able to eke out their existence until they plunge beyond the event horizon, whereas a tinier monster would rip them apart much sooner. Anything that falls into a black hole undergoes a process called spaghettification, in which they are stretched out into long, thin shapes resembling a piece of spaghetti. Cheers, my friends!